This is the solution to number 21 on problem set number 1. And the question is, how many positive integer factors are there of the number 2646? So before I go into that, I wanted to start with a much simpler number, so I chose 12. Because it's such a small number, we know that the factors are 1, 2, 3, 4, 6, and 12. So we want to figure out the most basic makeup of each of these factors. So 2 would be itself 2 to the first, 3 would be 3 to the first, 4 is 2 squared, 6 is 2 to the first times 3 to the first, and 12 is 2 squared times 3. So we use 2 and 3 as the basic makeup of each of these factors. So we can see that 2 squared is the highest exponent that is added to the 2, and 3 to the first is the highest that it goes for 3's. So we have 2 squared and 3 to the first is our highest. So we know that 2 to the first could either be 1, 2, or 2 squared, and 3 to the first is either 1 or 3. We know this because each of these is either 1, 2, or 2 squared times one of these values, either 1 or 3, such as 6, which is 2 to the first times 3 to the first. So you're picking a number and multiplying it times 1 in this column. So there are 3 options here and 2 options here. So that would equal 6 total options. So we know from this that the total number of options here, which is 3, and the total options of here, which is 2, multiply to give you the number of factors. So here we have 6, which we know there are 1, 2, 3, 4, 5, 6 positive integer factors of 12. So now we can move into a more complicated number that we have been given, which is 2646. So to figure this out, we can start with a basic factor tree to get down to the most basic parts of all the factors. So this can be split into 18 and 147. 18 can be broken down into 2 and 9 can be broken down into 3 and 3. 147 can be split into 7 and 21 can be split into 7 and 3. So all these factors that we have at the bottom cannot be broken down any further. So therefore we know that they will be used as our basic makeup. So for the 2's on the bottom, we only have 1, 2. Therefore we know the highest in the 2's is 2 to the first. For the 3's, we have 1, 2, 3 3's. So we know that 3 to the third is the highest that the 3's go. And for 7's, we have 2 7's. So we know that 7 squared is the highest that it goes for 7's. So once again, we can create our chart and we know that it's either 1 or 2 to the first for our first column. And for our second column, we know it's either 1, 3, 3 squared, or 3 to the third. And for 7's, we know it's either 1, 7 to the first, or 7 squared. So this is just opening up the list of possibilities that all these positive integer factors could be made up of. So in this column we have 2 different options, in this column we have 4 different options, and in this column we have 3 different options. So when we add up all these and then we multiply them together, we get 24. So we know that the possible positive integer factors, there are 24 of them because all the options multiply together to give you 24. So the answer for this one is that there are 24 positive integer factors of 2,646.